as well as the local extrema. So now we're going to move on to end behavior of a polynomial. So end behavior is a way to describe what happens to the function as x approaches positive and negative infinity without having to draw the graph. So let's just fill in end behavior because this is our definition. And we're going to take a look at a graph, and I'm going to show you some notation that you're going to start seeing and you're going to need to become familiar with. So first things first, I want to put arrows on this graph so that we're going to predict what's happening as it keeps going. So if I look at the right side first, the right side, my arrow is pointing up. And remember, we're going to predict what's happening as x approaches infinity. So as x approaches infinity, which means as I'm going further and further right, what's happening to my graph? My graph is going up. So the closer I get to the right to positive infinity, the higher my graph gets. So f of x is going to be approaching positive infinity as well. And remember that y is the same thing as f of x. That's just function notation. So now if we look on the left side, we have the graph going down. So over here, as x is approaching negative infinity, which means as I go further and further left, what's happening to my graph? My graph is going down. So that means that f of x is going to negative infinity as well because it's going down. So we can predict end behavior based on the equation of a polynomial. And there are 4 types. We can have an even degree with a positive leading coefficient. And it's going to look like this, where they both point facing up. So as I go further and further right, if I'm pointing up, my graph is going to positive infinity. As I go further and further left, or as x approaches negative infinity, my graph is still pointing up. So it's approaching positive infinity as well. So that's even degree, positive leading coefficient. Next is even degree, negative leading coefficient. So it's going to be facing down. Whenever we have an even degree, they both face in the same direction, and because it's negative, they're pointing down. So if I'm going to the right, as x approaches infinity, where is the graph going? Our graph is going down, so that means that it is approaching negative infinity. As x approaches negative infinity, which means I'm going to the left, the further and further left I go, where is my graph going? My arrow is still pointing down, so I am approaching negative infinity. So what's important is even degrees always match. They're either both up or both down. Odd degree. Odd is always opposite. So unlike even, where they're both facing in the same direction, odd, they're going opposite directions. One arrow points up, one arrow points down. So as I go to the right, or as x approaches infinity, my arrow is going up, which means that my graph is approaching infinity. As I'm going to the left, as x approaches negative infinity, the further and further left I go, my graph is pointing down. That arrow is pointed down towards negative infinity. And lastly, if I have an odd degree negative leading coefficient, our graph's going to look like this. It's opposite. So as I am going to the right, or as x approaches infinity, my graph is pointing down. The graph is pointing towards negative infinity. As x approaches negative infinity, which means I'm going to the left, so the further and further left I go, my graph is pointing up, which means my graph is pointing towards positive infinity. So these are your 4 cases. Even degree positive, they both face up. Even degree negative, they both face down. Odd degree positive, they're opposite and it ends up on the right side. Odd degree negative, they're opposite and it ends down on the right side.